Hi, and welcome to an algebraic video. This one is focusing on completing the square, which is really going to help us answer this essential question of how we can convert between standard and vertex form with quadratics. And it's also going to help us solve quadratics. And we're going to start with that, and then we're going to end with how we can convert. So first things first is a definition of completing the square. So all it is, as simple as I can put it, is that we're just going to add a term. And usually that term is just going to be a number that we add to it that is going to help us create this perfect squared trinomial. And as perfect square trinomial, if it helps, tri meaning 3, is something like this. So we have 3 terms, and then whenever it factors, it becomes something like this. Again, perfect square, things that have equal side lengths. So 3 times 3, or 3 squared, something kind of like that. So what I like to do is visualize what I'm trying to do here so I can actually see why they're calling it complete the square. So right here I have some algebra tiles, and usually these help deal with area. So notice this has a length x, the area is x squared. This has a length of x, this has a length of 1, so this is area x, and this is just a 1 by 1, so a 1 cubed. So I'm going to take this and try to use some tiles so that I can really see what's going on here. So I have 1x squared, and it looks like I have 6 of these. Holy cow, I have 6 of them. Well, if I'm wanting to make a square, that perfect square, it makes sense. If I want to make the sides equal, I need to make 3 of them on this side. And then I need to take these 3 and also put 3 on the other side. So really what I'm doing here is taking that 6 and just splitting it. So it actually looks like I have a square, but I still need to complete it. I need to put something right here. There's something that is missing, and I need to make it so that I have a perfect square. Well, hopefully you can start to see what should go there. Here's a 3, 3, so I need 9 of these pieces. And now what I have, I'm going to move this so it actually looks like a square, and there it is, a perfect square with the side lengths of x. See on those on both sides? And then you have the green pieces. Notice these each have 1, because that kind of matches here, but I have 3 of them. Plus 3 plus 3. So what we did is added 9 in order to get a square that has an area of this. I'm just trying to rewrite the area. Think of it like length and width, except because it's a square, I can make this look just like this. Squared. It's absolutely perfect. So this is kind of what I like about it, is I just go from this into this. So here's what we can do is I got some steps for you to, I think, help you see it. And then before we get there, I really want you to see what's going on here, because I love how I can visualize this and see why it's called completing the square. Because notice this number here, that plus 3 that you see at the very end, is right up here. And we got that because we took this middle term and divided it by 2 to make the square have equal sides. And then when we just wanted to complete it, we just squared that number. 3 times 3 gave us the 9. And that's actually where our steps come from. So when you are trying to do these, I like to keep the variables on the left, and I like to keep my constants on the right. So anything that's a number. And then I like to divide by a, because here's the thing. You don't want a 3x squared or a 2x squared. It just gets way too complicated. So I like to cross those off. We just want regular x squared. And then what you're going to do is add to both sides what we just did. We took that middle piece. Usually we use the letter B for the middle piece. We divided it by 2 because that got us to have equal sides. So 6 divided by 2 gave us 3 on both sides. And then we have to complete the square. Not too bad. And that'll give you that perfect square. And the nice thing is about steps 5 and 6 is these are really helpful if you plan on solving. But if you're not solving, you won't need steps 5 and 6. And I also have a little visual below, but I would pause the video and make sure you have these 6 steps written down, because I really think it makes it a little easier, especially if you're somebody that likes to have some order to things. But here in the meantime is another visual. So this whole thing has a length of b. I'm taking this and splitting it in half so I can start building my square. And then here's where I complete the square. So they have equal side lengths. I think this one's a little bit more confusing. That's why I like to use the one above. But let's go ahead and try a quick example, and I think it'll help you see what's going on here. First things first, I have to take this number, move it to the other side. So separating my variable side, my x's, from my constants or my numbers. 12x. And when I do that, this is where I'm going to add the blank because that's where I'm actually going to complete the square. So now I have negative 20 stuck on this side. And here's the thing. In algebra, if I add something to this side, if I keep it balanced, I have to add it to the other side. That's the way the algebraic world in mathematics works. It's like a balancing act. If I add 5 on one side, I have to add 5 on the other side. So on this one, make sure it's a perfect square. I'm going to take that middle number, in this case it happens to be negative 12, split it in half, complete the square, and it goes right up there. Easy way to remember it. Complete the square, goes right up there. So positive 36 here. Oh, positive 36 here. I got to keep it nice and balanced. And then I'm going to rewrite because this step right here matches what we did on the previous screen. Remember how I said we just split it in half and the numbers matched? It's exactly how we're going to rewrite it. If you are somebody that also is really, really good at factoring, that's really what's happening is I'm factoring this into this. It's just always going to turn out to be a perfect square. Then I need to make sure I square root both sides because this one I'm actually solving. Minus 6 equals, and not only do you get positive 4, because 4 times 4 gives me 16, but I also have negative 4, because negative 4 squared is also 16, so plus or minus 4. A lot of people lose points for that. And then we're going to go ahead and add 6 to both sides. And that's actually, and I'm going to go ahead and cross that off with yellow so you can still see my work. That's where we get both answers from. So I have x, I'm going to put my final answer in red. Negative 4 plus 6 is positive 2. Positive 4 plus 6 is positive 10. So that's where you always get those two solutions from when you complete the square. And you is done. What I would like you to do is pause the video and try to do example 2 by yourself. I'm going to leave my work up side by side, so when you pause the video, you can refer back to what I did. All right, hopefully, here's all the work if you need to see it, where I moved the 16 over, I completed the square to get down there. Ooh, look at that. All these fun rhymes with this video, I promise. It's so much fun to rhyme. So here's where that number came from. And then again, if you need to see the final answer, again, minus the 3, so you should have negative 8 as one of your solutions. And then when you have positive 5 minus 3 should be positive 2. So again, there's where both of the solutions are going to come from. And a lot of people think completing the square can be rather despicable, but I promise once you get to know them, just like the minions, it becomes a very friendly process. So what I'm going to do is show you an example where maybe the x squared is not by itself. I'm going to have something extra like a 3 in the front, and I got to decide what I want to do with it. So what I like to do is I like to take the 3 out, and I like to keep x squared. Now it's 6x, and I still am going to do my plus blankety blank blank blank. Again, we are going to fill the blankety blank blank with math and not with swear words because that's kind of how we're feeling. So I'm going to put 48 plus blankety blank 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 that we'll fill with numbers. All right, and we're going to continue our process. So I'm going to take 6 divided by 2, perfect square, goes up there. Here's the really, really tricky part. If I put 9, that's not necessarily keeping it balanced because remember, there's this extra 3 that we took out, and I only took it out of this side. I didn't really take it out of this side. So make sure whenever you do that, what we're going to have to do is do 9 times 3 to keep it balanced. So what goes on this side is actually 27. That's what makes these problems a little bit weird. And then what we're going to go ahead and do is leave the 3 right here. And I'm going to go ahead and do what we did. Remember that little shortcut we did? We're going to copy that answer. So I have plus 3 right here. Makes it a perfect square trinomial. And then on the other side, you're going to have 75. Now it kind of starts to look a little more familiar. So divide both sides by 3. So I'm still going to have this piece in blue. I'm going to keep that one so it can match. And then hopefully you're going to see it equals a very friendly number. And then hopefully from here you feel a little bit more comfortable. So square both root plus 3, and then always do not forget plus or minus 5. And then of course you'll get your two different solutions. But that's really what I want you to be careful about is this part with that 9 times 3. That's usually the biggest part that gets missed. All right. So what I would like you to do is go ahead and pause the video again, and I would like you to try example 4 by yourself. And this one's going to be a little bit interesting, so I'm excited to see what you can come up with. All right, welcome back to example 4. This one, hopefully you already noticed something that was different because there was a 3 in the front. So hopefully you took that one on out. And I'm going to reveal this because it's got a lot, and I want to explain a bit briefly before I let you check your answer, especially if you're not familiar with the last part in orange. So hopefully the first part went well. You took the 3 out, positive 1 times 3. So 3 had to go on the side to keep it balanced. Hopefully completing the square, we did well. It was probably when you tried to square root both sides that you're like, whoa, whoa, whoa. Square root of negative 9, that doesn't really have a perfect square. It can't be negative 3 because negative 3 times negative 3 is positive 9. So if you haven't already, I recommend watching one of my videos or another person's video about imaginary numbers. But right here's what you got to be careful of. Square root of negative 1 is really I, which is imaginary. I know that's really strange for you. So like I said, if you haven't seen that before, I highly recommend watching a video. And this is actually as simplified as it gets. All right, the last part of the video, what I want to focus on is helping you go from standard form, which actually matches this, which you have up here, into vertex form. Because vertex form is what is going to help you actually graph, because it literally tells you the vertex or the low point in the graph. So I think it's incredibly helpful to be able to go from this, which I can't graph, into this, which I can. So what we're going to do is actually try our very first example, example 5. And this is kind of the one we're going to end our lesson with. So what I like to do is I like to pretend this doesn't exist. It's not there. It's really not my concern. And I start the process like I normally would. So I take this 12 and I keep it nice and separate, just like I did before. So I have positive 12, and it's the same exact process, plus blank. And I know I'm kind of rearranging things, but I promise it's the exact same idea. I just like to keep it rearranged just so you can kind of see what I'm doing here. And plus blankety blank blank. Keep it nice and balanced. All right, complete the square. So 16, split that in half. Perfect square goes right up there. So here's 64. Again, no A. There's no number in here in the front, so I am allowed to just put 64 on the other side. All right, not too shabby. Let's make this a perfect square. So I have x plus 8 squared. And then on this side, 12, we have 76. So notice I did have an f of x on this side, and I'm not solving, I'm just merely rewriting. So the last thing that you're going to do is actually take the 76 and move it back to join the others. So that f of x, which is really there, can reappear. X plus 8 squared minus 76. And that is how you go from standard to vertex form, because now I can actually find the standard form of this equation. And then vertex is at negative 8, negative 76. And that's kind of the last part. So whenever you do try to graph this, it's just probably going to look like this, where I'm going to go negative 8, negative 76. So that's kind of why it helps us graph. So feel free to continue watching more additional algebraic videos by me. I'm really excited that you got to watch this one. Stay tuned for more exciting tips and tricks.